Let's talk about polygons. A polygon is a figure that is bounded by straight lines, like a triangle or a square. But an example that wouldn't be a polygon would be like a circle, because it's not made of straight lines. So important thing to consider when looking at polygons are diagonals. So a diagonal is basically a line segment that connects two vertices to each other. So for example, in this octagon, an example of diagonal could be this line segment, as it connects this vertex to this vertex. So let's look at some other diagonals. So from this vertex in particular, we can draw 1, 2, 3, 4, 5 diagonals. So we can create a sort of formula for this. So the number of diagonals that we can draw from one vertex would be n minus 3 because, well, there's total 8 vertices, or n, and we can't draw a diagonal to the point itself or the adjacent points because that would make it a side. So we can't draw it to 3 vertices in particular out of the total n. So it would become n minus 3 from one vertex. What about the total number of diagonals? Because we could also draw diagonals from this point to these points like this, right? So how many total diagonals can we draw? Well, if you think about it, since there's n minus 3 that we can draw from one point and there are n vertices, wouldn't it just be n times n minus 3? Well, it's not that simple. Because if we draw a diagonal from this point, and then once we make our way all the way over to this point, we'll draw the same diagonal again, which basically means that we counted all of our diagonals twice. So in order to get rid of this overcounting, our formula will become n times n minus 3 over 2 for the total number of diagonals. Another important thing to consider in polygons are its angles. So when looking at this figure in particular, how can we find the total sum of all of its interior angles? And interior angles are angles on its inside, like this one. So interior angles, well, if we look at our diagonals, they actually make triangles. So when we drew diagonals from this point in particular, we made a triangle like this. And when these stack up, we make triangles like this one, and this one, and this one. So when we draw diagonals from one point, we actually make all of these triangles on the figure. So how many triangles did we make? We made 1, 2, 3, 4, 5, 6. We made 6 different triangles. Since there are 8 vertices and we made 6 triangles, we could deduce that the number of triangles we make is n minus 2. So the total number of our interior angle degree measure would be n minus 2 times 180 degrees, because all triangles angles add up to 180. And all the angles in these triangles are actually part of our interior angles. So this would be the sum of all of our interior angles. So I keep saying interior angles, and it's time for me to introduce exterior angles, which are another type of angle, this, where if we draw a line like this, the exterior angle would be this. So how do we find this? Well, this has a simple formula where it's just 360 over n. And this is basically found by doing 180 minus n minus 2 times 180 over n, because n minus 2 times 180 over n would be each interior angle. So this is the exterior angle. So let's look at an example problem. So if we look at a hexagon, for example, let's try to find its features. So let's try to find the total number of diagonals first. So since the formula is n times n minus 3 over 2, the total number of diagonals would be, since n is equal to 6, 6 times 3 over 2, which would lead to 9 diagonals. So now let's talk about its interior angles and what they would add up to. Since the formula is n minus 2 times 180, it would be 6 minus 2 times 180, which would be 4 times 180, which is 720 degrees. What about its exterior angles? Well, that would be 360 over n, which is 360 over 6, which is 60 degrees. In order to verify that these formulas are right, let's run a little test. Since we know that the sum of all these interior angles is 720, and there are 6 of them, if this is a regular hexagon, that means that this angle is 120 degrees. Since 720 divided by 6 is 120. So if this is 120, and we draw a line like this to find its exterior angle, this should be 60 degrees. And it is, because 180 minus 120 is 60. So these equations are correct. Now these polygons can get a little confusing, so I've linked a practice worksheet in the description below, and you should go check that out. Bye bye.